Assalamu alaikum and hi again everyone. I'm Mohamed Behairy. I'm a second year medical student. Inshallah, in this PAL session, we're going to cover Intro to Metabolism. Now, if I'm being honest, this is one of the easiest lectures you have on the midterm, so please do not waste so much time on it. Everything in this PAL session, one time watching this PAL session should be enough, inshallah. Most of the information in this lecture are stuff that you took in high school. And even if not, يعني, they're very easy concepts, so inshallah, we're not going to waste so much time with them. I'll try to be done in 30 minutes or less, so you guys can focus on your other lectures, which are more important. طيب. So we're going to talk about metabolism today, as we agreed on. Now, in life generally, you can either build something or break something. There is no in between. You either bring a bunch of stuff to form a final product, or you get a final product and you break it into many different pieces. This is what anabolism and catabolism are. These are the types of reactions that happen in our body. Our body wants to build certain things and break down certain things. In this situation here, we have a bunch of random building blocks, whatever they are. In combination with energy, ATP, we are forming this final ready-made product. This is called anabolism. It is an anabolic reaction. We are getting these building blocks, bringing them together, and forming a final product. Now, this thing requires ATP. It requires energy. What's logical? If you want to build something, you want to make something from scratch, you need energy for that. Tamam? Now, with catabolism, with the way I like to remember it, catabolism, cats like to break things all the time. Oh, no offense, I'm a very huge cat fan. I have two cats, but they like to break things for some reason, always. That's how I remember catabolism is breaking things down. So we have this final ready-made product, and we're breaking it down into a bunch of blocks and building pieces and energy. This is what I want you guys to differentiate between in this slide. In anabolism, we are using energy to create something. But in catabolism, we are breaking something down, and after we break this something down, we are getting energy. So for example, in glycolysis, you guys took it, it's not on your midterm, but I hope you at least know when glycolysis is breaking down glucose and getting energy in the end at pyruvate. But this is exactly what we mean by the concept of catabolism. We're breaking down this glucose and getting energy in the end, and a bunch of other stuff. Right, so for those of you who like text, biosynthetic processes are called anabolic. We are building something, you need energy to build something, that's why they require ATP. So examples are, you don't need to memorize them, this is for the sake of just explaining the concept. Proteins are synthesized from amino acids. Amino acids come together to form this protein, and lipids that are synthesized from fatty acids. Degradative processes, where we break things down, are called catabolic, and they do not require ATP. They give you ATP, relax. And as I said, cats break stuff. That's an easy way to remember catabolism. Examples are glycolysis, we're breaking down glucose to produce energy, and glycogenolysis. You're breaking down glycogen to get glucose, because glycogen is the storage form of glucose. Now, you guys don't need to know all of this. These are just examples for you to understand the concept in the best possible way. طيب. Under steady state conditions, when the body is at homeostasis, when everything is normal, anabolism should ideally equal catabolism. The amount of building up should be equal to the amount of breaking down. Because why? We don't want a certain molecule to be in have a surplus. And we don't want a certain molecule to be lower than it has to be. So that's why we want everything to remain constant, ideally. Now, for this sentence, guys, don't go into detail. You don't need to know exactly what's involved in fuel oxidation. Just memorize this part. In fuel oxidation, we use oxygen and we produce carbon dioxide. That's all I want you to know. I'm trying to be practical for the exam. Do not waste time on this lecture. Just know this one piece of information. وخلاص يعطيكم العافية. طيب. Metabolic processes, they can happen in different parts of the cell. That's logical. They can happen in the cytoplasm, such as glycolysis. They can happen in the mitochondria, such as the electron transport chain. They can happen in the ribosomes, protein synthesis, يعني. whether it's anabolism or catabolism, every reaction, every pathway can happen in a different part of the cell. طيب, now this is an important concept. Where can a cell get energy from? I'm sure most of you will say glucose, and that is absolutely correct. But it's not only glucose. There is also fatty acids and amino acids. These three things can be broken down to give us energy. تمام? Most cells in the body, شوفوا, most cells, they have the liberty of choice. They can get their energy from glucose, fatty acids, amino acids. Yeah, that's what I want you to know. I was just contemplating saying this example, so I'm going to give it to you for the sake of understanding the concept. We have, for example, skeletal muscles. Usually they use glucose, but when glucose is in, let's say, scarce or it's not abundant in the body, it's going to use methylene fatty acids or amino acids. That's basically why cells have the liberty of choice. You don't always have enough from every one of those three. It's better to have multiple choices than having all your eggs in one basket. Now, there are two cells in particular that cannot use anything other than glucose. Their only choice when it comes to obtaining energy is glucose. Well, you need to memorize what they are. These two cells are RBCs, right? Right, red blood cells, and neurons, nerve cells. هذول الاثنين, their only source of energy is glucose, nothing else. Why? What's the reason? In all simplicity, they cannot metabolize the other molecules. Let's say we give an RBC a fatty acid. The RBC won't be able to break this fatty acid down. So how is it going to get the energy? So they are unable to metabolize the other molecules and therefore cannot generate energy out of them. So that is why RBCs and neurons depend exclusively on glucose. طيب, now we have a practice question. You guys can pause the video, then try to answer it yourself. I will be reading it right now. Which of the following statements is true for anabolic pathways only? Now, the answer for this question is D. They are synthetic and they require energy. Very self-explanatory. But why are A and B wrong? A and B are correct statements. Irreversible reactions are regulated, 100%. B is also correct. They are called cycles if they keep regenerating at a certain intermediate. But the reason why they are wrong is because they don't answer the question that we have in this question. They don't give us the piece of information that we're looking for. Well, this is what I want you guys to be careful of. In any exam you take in your life, be sure what the question wants from you. If the question was like, which of the following statements is true? Can قلنا, okay, A is correct, B is correct. But in this case, they're saying what statement is true for anabolic pathways only. Best anabolic pathways. A and B are correct for anabolic and catabolic, but they can't be the answer. That's why it's D. D, synthetic and require energy, this only applies to anabolic pathways. For the answer of C, I think it's obvious, generate a few simple products. That's catabolism. We're breaking down something and generating simple products. Right. Let's move on into an important concept, which is still very easy, metabolic pathways. طبعا شوفوا guys, we started by saying in the body we can break something or build something. But to do that, it's not as simple as one step. يلا, we want to make energy, يلا, glucose to ATP, على طول. لا, it's not like that. There are a series of steps that must be taken until we achieve what we want in the end. But in this case, this is the reactions involved in glycolysis. This is what your body goes through to create ATP from glucose. For what I want you to know from this slide is that a metabolic pathway is basically all of the reactions involved in a certain, let's say, creation of a molecule or breaking down of a molecule. So for example, this is the metabolic pathway of glycolysis, sorry. This is the pathway of glycolysis. This is the combination of all of the reactions that are used to convert glucose to pyruvate. تمام? So pathways are composed of many complex metabolic reactions. These reactions can be reversible or irreversible. Like, what do we mean by that? Let's go back. Let's take this individual reaction over here. Glucose 6-phosphate to fructose 6-phosphate. Wait, actually, let me use the pointer. This reaction. Let's take it and put it here. Glucose 6-phosphate, fructose 6-phosphate. A reversible reaction is a reaction that can go from reactant to product and from product to reactant. تمام؟ بس an irreversible reaction means إنه we go from reactant to product وخلاص. You can't go back. You cannot go back from that point. I hope this concept is clear. طيب. Now for regulation of metabolic pathways. Because if we don't regulate metabolic pathways and we don't control them in our body, هتصير حفلة. We will have an excess of so many things. We will have a shortage of so many things. We're not going to live. So we need to regulate these pathways. To regulate these pathways, there are three ways. First of all, adjusting the amount of enzyme. Well, logically, the more enzyme we're going to have, the more of a certain reaction will happen. The second way is regulating the enzyme's activity. This means going to the enzyme or interfering with it, doing something with it that will cause it to either upregulate, work better, or work less. Last but not least, feedback inhibition. It's feedback. Basically, the product will go to the first enzyme and tell it, خلاص, there is enough of me. We can stop the pathway now. Now, we're going to go into detail, obviously, with each of the three, but I just want you to have a general idea of them. Well, just as a quick note, feedback inhibition can fall under regulating an enzyme's activity. And if you want to regulate the activity of an enzyme, you can use feedback inhibition. But they are different concepts, yeah. طيب. So adjusting the amount of an enzyme. This is a long-term regulation. Why is it long-term? Then to adjust an amount of an enzyme, it means you either have to synthesize more of it or break it down. Well, this is not something that can happen in a split second. لا, it's something that might take time. فعشان كذا it's long-term type of regulation. It's not fast. As we said, it's changing the rate of synthesis, making it faster مثلا or slower, or degrading the enzyme مرة واحدة. And obviously, more enzymes means more of a certain reaction. Right, moving on. Now we're going to go to regulating enzymes activity. Oh, I want you to focus with me a bit here. It's an easy concept, but you have to focus to grasp the full concept. Let's start with the first way. If you guys can see, we have this enzyme called pyruvate kinase. But here, this enzyme is active, it's working. But on the other end, it's off, it's not working. But it's the same enzyme. We have the same concentrations of them. But why is the enzyme not working here or working here? In all simplicity, it has a phosphate attached to it. طيب, here comes the question. Does this mean that when an enzyme has a phosphate, it will be inactive? No, not necessarily. Oh, please grasp this concept well. Every enzyme has its own, let's say, type and preparations. Pyruvate kinase cannot work with a phosphate. They don't bond well. If you want pyruvate kinase to be on and working, you don't put a phosphate with it. But if you want to switch it off, you attach a phosphate to it. تمام? But other enzymes are the complete opposite. They can't work unless you have a phosphate. So you need to add a phosphate for them to work. Or if you remove this phosphate, they will not work. So I hope this concept is clear. This is the first way of regulating an enzyme's activity, adding or removing a phosphate. The second way is by what we call allosteric, basically, regulation. Now, شوفوا, this is pretty cool, يعني الصراحة, allosteric regulation, because it's non-competitive. It doesn't contain any competition. This is a substrate. It wants to go to the enzyme and react. حلو? One way of basically sabotaging this reaction is bringing something that looks like the substrate and making it compete with the substrate. Which one of them is going to go to this place of the enzyme and react? Hello? Now, you don't need to know this, but I just want you to grasp the full concept. That's why I'm talking about this. An allosteric regulator, it won't go to the active site of the enzyme, the place where the reaction happens. لا, it will leave them do what they want. يخلي whatever substrate can go to the active sites. It will sneak in and go to a place other than the active site, somewhere else in the enzyme. And the moment it goes there, it will do whatever it wants. That's what we mean by allosteric regulation. طبعا allosteric means other. So other regulations. We are not regulating the enzyme from the active site, from the place where the reactions happen. We are going somewhere else. It's not competitive, then it doesn't matter. If you have 70 million substrates, an allosteric inhibitor will manage to inhibit the enzyme. It's cold-blooded. It just goes, does whatever it wants, regardless of what's happening on the active site. I don't know why the video is not working, but basically what's happening, this is an allosteric inhibitor. We have inhibitors and activators. تمام? The inhibitor will bind to this place that's other than the active site. وخلاص, the substrate will not be able to react. This is what we mean by allostery. طيب. So for those of you who prefer text, we said in regulating an enzyme عندنا covalent regulation, which is by phosphorylation. Either the phosphorylated or the dephosphorylated enzyme is the active one. This depends on the enzyme itself, what it prefers. طب what is this process done by? It's done by enzymes. You regulate enzymes by using other enzymes. Those enzymes are protein kinase or protein phosphatase. Now remember, a kinase, anything that is a kinase will cause phosphorylation. If we want to add a phosphate to a certain enzyme, we will bring in protein kinase, or the protein kinase will put this phosphate. But what if we want to remove this phosphate? We will use a protein phosphatase. The phosphatase will go to the enzyme, which will remove the phosphate from it. تمام? The second type of regulating enzymes activity, allosteric regulation. As we said, we are regulating the enzyme by binding at a site other than the enzyme's active site. The active site is where the substrate binds. It's where the reactions happen. For the allosteric effectors, they absolutely ignore the substrate. They go somewhere else in the enzyme and do whatever they want. We call molecules that perform allosteric regulation effectors. Effectors that will increase the enzyme's activity, that will bind to the enzyme and increase the activity, are called activators, allosteric activators. Or the ones that will decrease the activity of the enzyme are called inhibitors. Very self-explanatory, I think. طيب. Let's go to the last one, which is feedback inhibition. Feedback inhibition, basically, in all simplicity, you are inhibiting the reaction. How? By feedback. We start this pathway with A. It goes to B, C, D, and the final product is E. Our end goal from this is E. طيب, how does feedback inhibition occur? This E, which is the final product, will go all the way back to the enzyme that makes A into B. It's going to go and it's going to tell it, hey, there is enough of me right now. يعطيكم العافية. You guys did a good job. We don't want any more of me. And not only do we not want any more of E, we also don't want to consume any more of A. يعني خلاص, we have enough of what we wanted in the first place. Why keep the reaction going? Or instead of this happening مثلا by a phosphate or ما أعرف إيش, لا, the product of the reaction itself will go back and tell the first enzyme to stop. طيب, for those of you who like text, a product that is formed later in the pathway can be an inhibitor of an activity of an enzyme that is earlier in the pathway. As we said, the final product goes early in the pathway or inhibits this. Now, in the body, specifically catabolic pathways, ATP is the most important when it comes to feedback inhibition. Why is that? شوفوا, most of the catabolic reactions in our body, the aim from them is to break something down to give us energy. What is energy? ATP. So when we have so much ATP, this ATP will go to the early in the pathway and it will be like, guys, there is enough of me now. The body has enough of me. There is enough energy. You can stop. So that's why reactions and pathways that involve breaking down things, catabolism, are the main regulator of them is ATP. So when ATP is scarce, when we don't have a lot of ATP, catabolic pathways are stimulated. we are breaking down more glucose, we are breaking down more fatty acids, we need energy. But when it's abundant, they are inhibited. طب who's going to go against ATP? يعني what's going to be the regulator of this pathway with ATP? It's ADP and AMP. Well, those two are products of ATP. Let me explain this to you. When we have a lot of ATP, it means we don't have ATP and AMP. لأنه you can't have both at once. If we have ADP or AMP, it means the ATP has been broken down. If we have the ATP intact, يعني, or it's normal, معناتها it's still not broken down, so we don't have ADP or AMP. So a lot of ATP will tell the body to stop breaking down stuff. خلاص, we have energy. But once this ATP is used and broken down, the ADP and the AMP will tell the body to continue breaking stuff again. It's like a cry for help by ADP or AMP. And now ATP is gone, it's all been used, it's broken down, we're the only ones left. Please break stuff again. This is basically what's going on. طيب. Now for another important concept, rate limiting and committed step. Let's go here, تمام? I'm going to explain this in the quickest way possible, inshallah. What does rate limiting mean in English? Rate is basically the speed, صح? It is like how fast something happens. Limiting, regulating. So we are limiting the speed of the reaction. That is the step. But what about committed? What does it mean to commit to something? It means that once you pledge your, let's say, allegiance to it, loyalty to it, خلاص. You don't go back. You continue in that direction. So let's look at the reaction here. We have 1 is becoming 2. But 2 has the option of going to 3 and going to 4. So this first reaction is not committed. لأنه the product has options. We're not committed yet. But after 2 becomes 4, خلاص. It only has one route ahead of it. Going to 5, then going to 6. So it's safe to assume in a reaction that takes us from 2 to 4, which is made by enzyme C, is a committed step. After the step happens, خلاص. You only have one route ahead of you. تمام? Well, the same thing صراحة can be said about reaction 2 to 3. But the thing is, there is nothing after 3. But صح, يعني after you go from 2 to 3, خلاص. That's the only thing ahead of you. That's committed. But what about rate limiting step? Rate limiting step simply refers to the slowest reaction in a pathway. It is the slowest one. That's why it limits the speed. لأنه the faster it happens, the faster the pathway happens. Or the slower it happens, the slower the pathway happens. But it is the slowest reaction, or it basically dictates the speed of the whole pathway. But can we see the rate limiting step here? Ideally, no, لأنه we don't have the speeds. ولكن in most cases, 99% of the times, the rate limiting step is also the committed step. They are the same step, يعني. لأنه logically speaking, the step that is committed, the one that خلاص you're going to dedicate the whole pathway in a certain direction to, it's also going to be the rate limiting step. It's going to be the slowest one, logically speaking. In this case, we're going from 2 to 4. This is the committed step. خلاص, we only have 5 and 6 after us. We're dedicating ourselves to a certain route. This same step is also going to be the rate limiting step. I hope this concept is clear. Now, for those of you who like text, the rate limiting step, it is the slowest reaction in the pathway. It controls the overall speed of the pathway. While the committed step, it is the step where خلاص, the reactions can only proceed in one direction, in one pathway. يعني خلاص, after the committed step happens, we don't have options. مو زي هنا we go from 1 to 2, but then we have 2 different options. لا. After the committed step, you don't have options. The reaction will proceed in one direction. In a pathway, as we said, the rate limiting step is usually also the committed step. They're the same step. Well, these steps are highly regulated. طبعا, this is very logical. The step that is the most important, that is the committed one, that is going to be the one that will decide how fast the pathway happens will be the one that is regulated the most. طبيعي. طيب. The remaining 4 slides of the lecture, in your lecture, يعني homeostasis, I don't get why exactly it was included. It's a bunch of foundation material that is very logical or self-explanatory. But I just brought the most important points and put them. لأن the other things يعني they don't really require any explanation and not even memorization. لأن it's things that we already know. But these points are very important, so focus on them. The most important mechanism of homeostasis in the body is by ATP. لأنه ATP has so many functions, whether it's contraction of muscles, whether it's for certain reactions. But in this case, we want to focus on ion pumps. Guys, ion balance between cells is so important, very important. Just a teeny bit of imbalances in ions in between cells will cause disasters. So that is why the most important function of ATP when it comes to homeostasis is maintaining the ion pumps, making sure there is an equilibrium يعني basically, or maintaining the osmolality. تمام? If ATP levels fall, the remaining ATP molecules will shift towards essential survival functions. But what does this mean? Usually, مثلا, ATP is going to our brain to help us think. It's going to our muscles for muscle contraction. But when ATP levels goes down, they will leave your muscles or they will go to the more important stuff, the stuff that you can't survive without, such as ion transport. Or your muscle ad, as we said, it can use different sources of energy. It will probably use amino acids or fatty acids. During fasting, when glucose is low, some cells will switch from glucose oxidation to fat oxidation. This is what we said. And when ATP is low, your muscle, خلاص, it will no longer use ATP or glucose. This glucose, or not will not use ATP, it will not use glucose. So this glucose will go somewhere else for neurons. But why are neurons a priority? They can't use anything other than glucose. تمام? Or the muscle will then use something else, fatty acids. It will get its ATP from a different place, يعني من الأخير. طيب. For this last slide, it was discussing the function of different hormones. So I'm just going to explain them from this picture. You have insulin, which wants to lower blood glucose levels. This happens after you eat a heavy meal or a meal in general. Or you have glucagon. Glucagon wants to bring up the glucose levels in the blood. Or this is usually secreted when you're fasting, but they go against each other. But then we have epinephrine, and he's trying to help. Epinephrine, we know it's another word for adrenaline. What does adrenaline do? It's basically the fight or flight in your body. We talked about this in the autonomic nervous system part during foundation. The epinephrine, when your body is in a state of fight or flight, we need as much energy and sugar as we can possibly get. خلاص, you're trying to escape a very tough situation. مثلا, you're being chased by a lion or something. I don't know. So we need sugar in this situation. We need the energy. So that is why epinephrine is with glucagon. That's how you can remember it. And both of them want to increase the glucose that we have. While insulin does the opposite. تمام? We have a fourth hormone. الصراحة I didn't include it لأنه it's literally 3 words. Cortisol is a stress hormone. This is all you need to know. حرفيا. طيب. With the last practice question for today, which of the following enzymes catalyzes the committed step for the pathway leading to the formation of product 6? يعني هو قاعد يسألك السؤال, which one of these enzymes creates the reaction that forces the pathway to go in the direction of creating product number 6? You can pause the question or try to answer it. This is the same exact question that was in your slides, but I added it just to make sure we understand the concept or to explain it. The answer in this case will be C. لأن enzyme A will make a reaction, will create a product that can have choices. That is not a committed step. The committed step is a step in which afterwards, خلاص, we can only head towards one direction. وهنا they specified, they said, what is the committed step that takes us to product 6? It has to be C, this one. It can't be B. They said we want product 6. وإف this question, instead of committed step, قالوا regulate, مو regulated, rate limiting step, we would also say C. ليش؟ إنه we agreed إنه in most cases, the committed step is also the rate limiting step. Thank you very much. This was it, يعني, for today. I wish you the best of luck on the midterm. Inshallah, this was an easy lecture. As usual, if you have any questions, please feel free to contact me anytime. This is my phone number. Or please, if you have the time, scan this QR code, give us your feedback on the session so we can do our best to improve, inshallah, in the future. Other than that, thank you guys so much. Best of luck in the midterm. يعطيكم العافية.